Alright, problem number 5. When three numbers are added, two at a time, the sums are 73, 27, and 48. What is the sum of all three numbers? Alright, well, let's assign some variables. I'm just going to call the three numbers x, y, and z. So I know if I take two of them, let's say we take x plus y, and that equals 73. Alright. Take another two, say we take y plus z, and that's equal to 27. And then finally, let's say we take z plus x, and we get 48. Alright. So now we've taken our statement in words and turned it into equations. Now we have three linear equations and we have three unknowns. So we could actually solve for x, y, and z and then add them up and get the sum of the three numbers. But what I'm seeing here is that if I take these three equations and add them up, you see I have two x's, I have an x and an x here, I have a y and a y here, and I have a z and a z here. Alright, so I'll end up getting two x's plus two y's plus two z's, and that will add up to, if I add all this up, let's see, this is an 8, it's 18, so what is that, 148, right? Because I have 10 plus 4, that's 14, okay. So, look at that, I have 2x, 2y, 2z, I can actually factor out a 2. 2 times x plus y plus z is equal to 148, and if I divide both sides by 2, right, I get x plus y plus z is equal to 74. Alright? And that's the answer, 74. Now you may not have, you might not have seen that, that you could do that, but you could easily use this equation, and you've got y plus z equals 27, so you could say y is equal to 27 minus z, and you could say x is equal to 48 minus z. Alright, and then we can plug x and y into this first equation, and so we have x plus y, so x is 48 minus z plus y, which is 27 minus z, is equal to 73. Okay, that's just using these two equations, and wherever I see y, I put 27 minus z, wherever I see x, I put 48 minus z. And now we've got everything in terms of one variable. So we have a negative 2z, right? Because we have a negative z here, and 48 plus 27 is 75. So we have 75 minus 2z is equal to 73. Now I can add 2z here, z, and then I can actually subtract 73 minus 73, and then I'll get 2 is equal to 2z, oops, 2z, so z has to be equal to 1. Now the problem didn't ask for these numbers, but this is just another way of solving it, okay? They didn't ask you to solve for each of the variables. This is the quick way to do it, alright? But in case you didn't see that, you want some proof that that actually works. I'm doing it the other way, okay? So if I have z equals 1, and then I can solve for x and y, right, using these equations right here. So I'll get x is equal to 48 minus 1, if z is 1, so that's 47. And y is equal to 27 minus 1, which is 26. And then we have z equals 1, Okay, and if we add those up, we get x plus y plus z is equal to, and it should be the same thing, right? Should get 74, which we do. All right. So that's just another way of doing it. But before you launch into a lot of, automatic calculations doing substitution, this is the normal way, when you see these kinds of problems, this is the normal way that you would do it. But, look at it first. And you might see that when you add the three equations, you get this 2 times x plus y plus z. And then that could save you some time. All right? So there you go.